morning. Good morning. Well, it's a good thing I can't sleep very well lately. I'm not sure why, but there are some things that are sort of aggravating me in the world. But that's not what you're here to talk about. You're here to talk about circles and solving equations. Getting ready for that Regents exam in Algebra 2 and trigonometry. Hopefully, this helps out a little bit. First thing we're going to talk about is circles, and then we're going to do some crazy solving of some crazy equations. Like, for example, some of these. These look like fun, don't they? Man, I'm not going to solve all of those, I hope. Holy mackerel, I'll be here all night. I'll solve most of them. Maybe I'll do them all. The file should be downloadable if you can't find it. You shouldn't be just watching me do this video. You should probably have this thing either downloadable or printed out. MrKrausMath.com. Go over there, click on the Regents review. Kraus is spelled Krause. And then click on Regents review. Somewhere down at the bottom near there, it's going to talk about after school review sessions or something to that effect. And you should be fine. You should be able to find one that says circles and solving equations. This one's my day 2 of after school review. All right, without further ado, I will take me some burgers coffee because it's early in the morning, and you know me. Well, by the way, just in case you're wondering and you can't see that clock, it's 3:23 in the morning. I actually do my best work here. By the way, I used to in college, just in case you all really don't care, get up, go to bed a little early, and instead of doing all-nighter, I used to get up and start working at 3:30 in the morning just so I would be ready for whatever I had to do. All right. I'm going to take my highlighter out and see what we got here. We got a radius of 18 inches. We want to go to the nearest inch. Does the wheel travel when it rotates in an angle of 2.5 radians? So, first and foremost, there's not too much we've done with circles this year. There's my wheel. Woo, that's not even bad. It's got a radius of 18 inches. And it travels through angles of 2/5 pi, which is a little less than 90 degrees. Because pi is 2.5. Pi would be 5 pi over 5. So this is a little less than half of pi. So it's a little less than 90 degrees. But we want to figure out how far it has traveled. We want to figure out what the distance is that it's traveled when it's gone a little less than 90 degrees. It's probably about that much of an angle. I'm not really sure. It doesn't really matter. So at this point, you should know that you have to use the formula S equals theta R, where theta must be in radians. Well, the good news is we're starting out with an easy problem. And this is my radius. Well, that's pretty simple. We just go S equals 2 pi over 5 times 18. Come over to my calculator, go into calculator mode, go into control. We'll try calculator mode. What the save anything, I don't even know what that is. So control division, 2 pi over 5 times 18. Enter. And we get 22.619. S equals 22.619. Let's go 23. Ka-ching, one done, 4,000 to go. A circle is drawn to represent a pizza. Ooh, real life problem. Wait a second now. Careful now, we got a diameter. Remember, this formula deals with radius, not diameter. So we got diameter of 12. It's cut into 8 congruent pieces. What is the length of the outer edge? All right, so here's the easy way to do this problem. Let me show you 2 different ways to do the problem. Take our pizza. We're going to cut it up to 8. That's 4. That's 8. So we need to figure out first of all, let's talk about our formula. S equals theta r. We know what r is. R is 6 because it's 6 inches. We just don't know what theta is. So there's a couple ways to do this problem. One is I could take 360 degrees and I can divide by 8 and I would get 45 degrees. And then I would, but you got to convert it to radians, so I can multiply by pi over 180 and eventually end up with pi over 4. But instead of thinking about a circle as 360, if you're grown up and you're in, sort of in trig class now, you're sort of more grown up, isn't a circle also 2 pi? So if I know I have to get to radians, why not go right to 2 pi? And 2 pi reduces to pi over 4. So that's what we're going to put here. Pi over 4. So my final answer is 6 pi over 4, which is not over here, but 6 pi over 4 reduces to 3 pi over 2. Done with 2. Mr. Letta has a clock with a diameter of 20 inches. If he begins watching the clock exactly at noon and stops watching it at 12:35, exactly how far has the point of the minute hand traveled, assuming that both the hour hand and the minute hand are the same length and travel on the edge of the clock? Blah, blah, blah. So this is the minute hand. Don't worry about, we don't even care about the hour hand. There's where the minute hand starts. And it travels to 12:35. Well, there's 12:30. And then there's 12:35. So the minute hand would be at the 7, right? So I want to know how far the point on the outside has traveled. How far has that point traveled along the outer edge of that circle? All right. Well, the hardest thing to figure out is what the angle is. So let's deal with the easy part first. S equals theta r. The radius in this case would be 10. Be careful. Even though the diameter is 20, we only need the radius. And so now we just got to figure out what this angle measure is. Well, it went from 12 all the way over to here to 7. So didn't it travel 7/12 of the clock? Now I can do 7/12 of 360 to figure out how many degrees it is and then multiply by pi over 180. Or I can just skip that step and multiply by 2 pi. Because it's 7/12 of a circle. 7/12 of 2 pi. Well, this is just 14 pi over 12. Or 7 pi over 6. Didn't tell you what to round to. So I guess we could not round this one. So the answer is 140 pi over 12. Or if we reduce this, let's see, 2 goes into both those, 4 goes into both those. Just take it. Should be 35 over 3, but let's just make sure. 140 divided by 12, 35 over 3. Just as I assumed. But assuming, it's not always the smartest thing. I just started another application that ought to slow the thing down. So 35 pi over 3. All right, so everything's going to get a little slow on the computer for a few minutes, but then I'll just close that application out. Okay, so see how everything's dragging now? I think I need a new computer. All right, I got to get rid of this application. Hold on. All right. We should be better now. All right, circle radius. Find the arc length. Arc length. We got to find x to the nearest tenth. So again, we're going to use the formula S equals theta are to find x, s equals, now the first thing we're going to have to do is convert this degrees and minutes into radians. So 34 degrees, 20 minutes, and we're going to multiply by pi over 180. So we'll go to our calculator. Now to go to degrees, minutes, seconds, I got to go in here, hit that puppy, and 34 degrees. Totally forgot what it was. Was it 20 minutes? 20 minutes. Sorry about that. 20 minutes. That's just because it's early. And then we're going to multiply by pi divided by 180. And that's what we get, 0.599229. So 0.599229. And you really shouldn't be rounding. 709,851. 709,851 times my radius, which is 15 centimeters. Didn't need to put those units in there. So really what I'm going to do is come over here and hit times, because I want to take the second answer, and we're going to multiply by 15. And we get 8.988. 8.988. Round to the nearest tenths. All right, well, that's easy. 9.0. I got screwed something up there because I remember that problem being that way. But there we go. I guess that's it. All right, let's go to the next problem. So this problem I want to make sure we understand. I want to find the angle now. All right. So what we're going to do is still use this S equals theta R. And actually, we're not in bad shape here. S equals theta R. I forgot to put, I don't know why I put two equal signs in there. In this case, I tell you the radius, or the arc that's traveled is 42.6 centimeters. And it's equal to theta times the radius, which is 19. So if I divide by 19, I divide by 19. And I get theta equals 42.6 over 19. And now that's radians. But the question says find angle x to the nearest minute. So the first thing I'm going to have to do is convert this to degrees by multiplying by 180 over pi. So I get theta is equal to, I don't know, 42.6, 42, I should probably do it this way. Oh, this is driving me crazy, all this stuff on here. So control division, 42.6 divided by 19. And we're going to multiply by control division 180 over pi. So that's how many radians. That's how many degrees we have. Excuse me, we converted degrees. But the question says, what is this to the nearest minute? So you have to DMS this thing. So we go into the catalog, this book right here. And, you know, in the TI-84, you just got to go into the catalog and find DMS. You're going to DMS it. It's always fun to say. So we're going to go 128 degrees. And I'm going to write it all down. 128, 27, 47. So it's 128 degrees, 47 minutes, 27 minutes. Doggone it. (27 minutes, 47 seconds). All right, so the question says to the nearest minute. Now, this is the nearest minute right here. We're going to round this 47. So what we have to do is look here, or this 27. We're going to round this. I have 47 seconds. Actually, I really don't even care about this. I care about this. And since that's a 4, and that really is 47 seconds. 47 seconds is past 30 seconds, because I really only care about the 4. So that really represents 40 seconds. That's past 30 seconds. I got to round up. Remember, 30 is the rounding number, not 0.5, not 5. We're looking for a 3. So 128 degrees, 28 minutes. All right, moving on. How many more do we got to do? All right, if you got it, you might want to skip by a few of these if you understand these. I don't think, I don't know. Stop on each problem. Maybe I'll tell you at the beginning, I'll tell you if it's really a hard problem or if you should do it. Arc length is 12 inches and the radius is 4 inches. Find theta. So 12, that's the arc length, is equal to theta times r, 4. Oh, theta equals 3 radians. Didn't say how degrees or if it didn't say degrees or radians, there's the answer. Now, if I wanted, again, that's radians. If I wanted degrees, I'd have to multiply by 180 over pi, and I would just come over to my calculator. This should be close to 180 because 3.14 is 3.414 radians is pi. So 171.88. If they asked. If the arc length is 12 inches and theta equals 6, this should say 6 radians. This is a poorly worded problem. Sorry about that. Find the radius of the circle. So 12 is equal to 6 times the radius, so the radius must equal 2. Done. If theta equals 2 pi, I don't know why, this is really awful. This should say 2.5 radians. I wish I hadn't made these copies already. This should say 2.5 radians. And the diameter of the circle is 8. Find the arc length. So you'll do S equals 2.5, but we have to multiply by 4 because it's the radius, not the diameter. Remember, this is the diameter. So this would give me S equals 10. 10 what? I don't know. Because it doesn't have units. So it's 10. Whatever 10 is. It'll be 10 miles. A pendulum swings through an angle of pi third radians every second. If the pendulum is 40 inches long, how far does the tip move every second? So pendulum starts here. It swings here. So how far does the tip move? It's this arc here. We have an angle of pi over 3 every second. So it's just a simple S equals theta r. Here's the length of my pendulum. It's 40. So, and again, it doesn't tell you to round. So in this case, it's just S equals pi over 3 times 40. So this is 40 pi over 3. And that would be a good enough answer. I mean, if they ask for you to round it to the nearest tenth or whatever, you can just type that in your calculator. All right, the central angle, slice speed, and the radius is 7.5. Find the arc length. Well, I'm not going to go through and tell you how to convert 45 degrees into radians. You should just know that that's really pi over 4. If you don't, you take 45, you multiply by pi over 180. So this is pi over 4, and we're going to multiply by 7.5. This seems like, since it's a food question, this is probably not an acceptable answer because it's a food question. I want to know how long my crust is. So I'll take 7.5 and I'll multiply by control division pi over 180. Now, what am I doing? That's not what I want. Well, it wasn't pi over. What am I doing pi over 180 for? All of a sudden, my brain just cramped. Pi over 4. Oh, man, how dumb was that? I mean, my crust, does it make sense that my crust is 0.13 whatever inches long? Ah, 5.89 inches. And again, they'd have to tell you where to round to. Otherwise, you have to write down all the decimals. They don't tell you where to round them, don't round. All right, here we go. Some more fun stuff. Now, it seems like all this stuff's all crammed up here. Now, here's how I go about handling complex problems like this. The first thing I want to do is never have a minus sign in the middle. So I'm going to change this to a plus and put this to a minus because that bothers me a little bit. And you'll see why in a second. Well, maybe not on this problem, but maybe it'll come up later. So what I want to look for is the lowest common denominator. And in this case, the lowest common denominator is, now be careful, x minus 1 is its own thing. It's all by itself. It is x minus 1. So in this case, the common denominator is really x minus 1. X minus 1. That's the common denominator. So what I'm going to do is I'm going to take every one of these fractions and multiply it by x times x minus 1. Now this seems time consuming. There are other ways to do this problem, and you'll see why the magic happens in a second on these. So if I take this fraction 1 over x and I multiply it by x times x minus 1, these x's cancel each other out. So I'm left with 1 to distribute into here, so I'm just really left with x minus 1. Notice it's no longer a fraction. On this one, this x minus 1 cancels with this x minus 1, and it leaves me minus 2x. And on this, the x's cancel, and I got to distribute the 2. So I'm left with 2x minus 2. All right. I want to bring, let's see, we're going to combine like terms, so we'll just do this. This gives me negative x minus 1 equals 2x minus 2. We'll bring the x's over, so I get, so I'll add x, and then I add x, and I get 3x, and then I'm going to add 2, and add 2, and I get equals 1. And then I get the crying, oh my god, I must have screwed something up. When you divide by 3, you get x equals 1/3. That can't possibly be right. No way that could be right. Well, let's check. So, first thing I'm going to do is control division. I'm going to store 1/3. I'm going to stow it into x. And I'm going to type in that problem, which I don't remember what it was. 1 over x. So, control division 1 divided by x minus control division. That's control minus. That doesn't really help us out at all. Control division 2 over, I believe it was x minus 1. And I'll hit enter. 6. Then I'll do the other side. The other side was 2 over x. Control division 2 over x. 6. Since these match, I'm correct. And you can check all these answers. It's awesome. It's a wonderful thing. So here my common denominator is 2x. So I'm going to multiply every one of these by 2x. 2x, 2x, and 2x. Here the 2's cancel, and I'm left with x. Here the 2x's cancel, and I'm really left with negative x plus 8. Here the x's cancel, and I'm left with 2. So I bring this x over, I get 2x equals 10, or x equals 5. I'm not checking all these. I'll check a couple of them. Common denominator on this one is 12x. 12x. There's my common denominator. So I'm going to multiply everything through by 12x. Twelve goes and cancels with that 12, leaves me x. This x cancels with this x, it leaves me 12. And this 4 goes into 12 3 times, so that leaves me 3x. I'll subtract the x over, and I get 2x equals 12, or x equals 6. Now, if you're just watching the performing monkey go, I'm not a performing monkey. Stop. This next problem is really hard. So I'm going to have to take me some little bit of Brugger's coffee. This problem is a ka-chang. Tough problem. Like the last two were a joke. This one's tough. Alright, so the first thing I'm going to do is get rid of this. and put the minus right there. Now, this is x plus 5. This is the problem. And this, I already know I'm going to think about this as being x plus 5, x minus 5. It's the difference of perfect squares. So I'm going to copy all this down. 2x over x plus 5 plus negative 1. I'm going to come back to that one. 10 over x plus 5, x minus 5. Now, if I left this as 5 minus x, I would have to use a lowest common denominator, because remember, the lowest common denominator has to have all the pieces. I would have to make it x plus 5, 5 minus x, and x minus 5. I'd have to make it all three of those things. And it would really, truly be a legitimate pain in the keister to do it that way. So I don't really want to do that. And this is my problem right here. And this is something you should start to look at. This is backwards. This screams the negative 1 rule. If I take, I'm going to put it over here, 5 minus x, and I say, look, I'm going to take a negative 1 out. Put a negative 1. I'm going to factor a negative 1 away from these. Well, in order to do so, wouldn't that be 5 plus x? Excuse me. Negative 5 plus x. Negative 1 times negative 5 is positive 5. And negative 1 times positive x is negative x. Or I can think about this as being negative 1 times x minus 5. So really what I have here is negative x minus 5. That's why we call it the negative 1 rule. Anytime something's backwards, I can flip it around and change the negatives. Well, hold on a second. Then don't these two negatives make a positive? Ah. Now my lowest common denominator is x plus 5, x minus 5. And you'll see that this makes this problem a lot easier to deal with. So I'm going to put an x plus 5. Yes, this is time consuming. Yes, I know. But you're only going to do one of these problems on the test. Do it the right way. Multiply by x plus 5, x minus 5. Even I do all this every time. X plus 5, x minus 5. It clarifies your thinking. We'll grab the blue pen this time. The x plus 5s are going to cancel. Now you're going to distribute this into here. So you get 2x squared minus 10x. These x minus 5s cancel. Luckily, I just have to distribute a 1 here, so that's easy. Plus x plus 5. And this cancel, and I get equals 10. All right. Good news. Everything's come to the left side. We have a quadratic to solve, so I get 2x squared minus 9x minus 5 equals 0. Now, if you can't factor this, you can always come over to the calculator and do menu 331 in this particular case. Hopefully you have this calculator. And my coefficients were 2, couldn't remember if it was 9 or negative 9. Negative 9 and negative 5. And hopefully if I did this correctly, hit factors, hit enter. Ah, there are my two answers. Negative 1/2 and 5. That's not my factoring. Those are my answers. X equals 5 and x equals negative 1/2. Well, this is easy then. It's just x minus 5. So this one's a little more tricky for those who haven't seen me do this in a long time or seen me show you how to factor. This 2 really came from dividing by 2x. So that's 2x. And this 1 really got to go back over here. That's because it's plus 1. And you can check the math. So those are my two answers, 5 and negative 1/2. So the one thing I haven't talked about yet is checking your answers. So 5 and negative 1/2. Well, let me erase a little bit and go back to my original problem. One of the things you need to look at is what makes these fractions undefined. What values of x can't I have in my solution? Well, there are two answers to that. I can't have a negative 5 because that would cause this to make it 0. And I can't have a positive 5 because that would make this 0. So this answer is actually no good. You could find that out easily by checking your answer. For example, let me get rid of all this stuff. If I did 5 stow x, I stowed 5 into x, and I typed this problem in, 2x over x plus 5, control division, 2x over x plus 5, minus 1 over 5 minus x, minus 1, control division, 1 over 5 minus x. Now the goal is you put the left side in and then you put the right side in. I press enter, it's undefined. And it's undefined because you have a division by 0 arrow right here. That would be 5 minus 5, and that would be division. So it's restricted in the domain. 5's got to be canceled. So I can't tell you enough. You must check all of your answers because you don't want to do all that great work and then realize, oh crap, I should have crossed off one of those answers. All right, we're going to do, looks like maybe 5 more of these. You don't have to do them all with me. While you're looking at it, let me tell you which ones are the really hard ones. 18's a little bit different because the 2 doesn't have a denominator, but that's actually a pretty easy problem. And 19's going to be tough. So if you're looking to do maybe a couple problems more, 18 and 19, I'm going to do all of them. Skip ahead, don't skip ahead. I don't really care. If you want more practice, if you've tried these problems, you want to see how they're done, I'm going to do them. Because that's the guy I am. And I got no other life, and it's 3:54 in the morning, so what else do I got to do? So, common denominator here is 12x. So we're going to multiply everything through by 12x. 12x, 12x. Actually, I really have a headache right now. 12x. So here the 4 cancels and goes into 12 3 times, and the x's cancel. So I'm going to distribute that 3. So that's 9 minus 3x squared. 6 goes into 12 twice, so that gives me 10x because you're going to take the 5 and you're going to multiply it by 2x, so that's 10x. And 12x cancels with 12x and I get 1. So this is a quadratic, but my squared term or my quadratic term is negative. It's right here and it's negative. And you never ever want to try to solve quadratics with this being negative. So we're going to move it. We're going to move it all over to that side. So this side will be 0. That will be positive 3x. When I bring the 10x over, it's going to be minus 10x. And I also have to subtract this 9, so I get minus 8. So let's practice with the 3, 3, 1 again. By the way, I know this is going to be 3x and x. Just so you know, this will be minus 4 and this will be plus 2. But let's go take a look to see if the calculator will give us 2 answers. I don't want you to think I'm not smart enough to factor. So menu, 3, 3, 1. It's a second degree polynomial. We've got 3. I think it was 10. I don't remember if it was negative 10 or positive 10. Of course it was negative 10. Negative 10. And I forgot now. Negative 8. Negative 8. Man, I'm getting old. And we'll hit enter. And we get 2/3 and 4. So x equals negative 2/3 and x equals 4. Again, this 3 goes here. And then the 2 came back and made it a plus 2. And this was just x minus 4, which is kind of what I told you the 2 answers were. In this case, the 2 answers are, in fact, negative 2/3 and 4. and you can trust that I checked them. The only answer, by the way, if you look back at the only answer that wouldn't be acceptable here would be 0. You can't have 0 as a solution. All right, moving on. In this case, this is really over 1, and my common denominator is 2x minus 1. There it is right there, 2x minus 1. So I'm going to multiply everything through by 2x minus 1. So 2x minus 1, 2x minus 1, and 2x minus 1. So that cancels with that, leaves me 3x squared. That cancels with that, leaves me plus 3x minus 4. And then this one I got to distribute. So negative 2 times 2x is negative 4x, and negative 2 times negative 1 is positive 2. Take care of those signs, kids. I'm telling you that multiplying this negative 2 times this negative 1 and getting a negative 2 is not acceptable. All right, so we get 3x squared. Our x squared term is positive. We're going to bring this 4x by adding it over, so this becomes plus 7x. And we're going to subtract this 2, so this becomes minus 6. Equals 0. So let's see if we can just factor this. We'll check our answers. How about that? We'll check using menu 331. This is going to be plus 3 and minus 2. So my two answers are x equals 2/3 and x equals negative 3. Let's just check. Menu 331. 3, 7, negative 6. Enter. 3, 7, negative 6, negative 3 and 2/3, negative 3 and 2/3. There's my two answers. Should we check? Oh yeah, we should check. I'm not going to because this video will take forever. The only answer that wouldn't work, by the way, here is a half. You know, the only thing that would make this denominator equal to 0 would be a half. You can check those answers if you want, but I'm pretty sure they work. All right, so let's go. Common denominator here is 4x, so we're going to put a 4x next to every one of these. So here, 2 goes into 4 twice, so that gives me 2x. Equals, the 4x is canceled, leaves me x squared minus 7x plus 1. 2 cancel the 4 twice, and the x's cancel. So I'm left with minus 2. Well, my squared term is positive. I want it to be positive, so I'm going to bring this 2x over. So I get minus 9x minus 1. Four x, and 4x, 2x, x squared minus 7x plus 1, minus 2, positive 1. Well, I'm not sure what the directions are where I stole this problem from, but this one is not factorable. So in this particular case, we'll have to use the quadratic formula. So this will give me an opportunity to teach you or remind you about how to do the quadratic formula. I use A, B, C, D. Your teacher may not use D. D for me stands for the discriminant. So A is 1, B is negative 9, and C is negative 1. The discriminant, remember, is B squared minus 4AC. It's the part that's under the radical. B squared is 81 minus 4 times 1 times negative 1. Well, this is really just plus 4, so this becomes 85. So, if you remember correctly, x equals negative b over 2a plus or minus the square root of b squared minus 4ac, which is just d. We've already done that work. all over 2a. And did you notice when I put in b squared, I just put in 81. I didn't put in negative 9 squared. Because if you try to put in negative 9 squared in your calculator, most modern calculators will tell you that's negative 81, which it is not. So when you're using the quadratic formula, actually put in just it's 81. You know it's 9 squared. It's 81. All right, so let's see if we got here for a final answer or for an answer. We're going to go x equals negative b. So that's positive 9 over 2 times 1 plus or minus the square root of 85. I already did the work, all over 2 times 1. All right, so my answer is x equals 9 halves plus or minus the square root of 85 over 2. Now, that's the exact answer. 85 can't be simplified. You should look to see if 85 can be simplified. There's no perfect square that goes in 85. The only thing that does multiply to 85 is 17 times 5. So that's pretty much the answer. All right, we're done. Let's move on. Don't know where my pound. So I'm going to get back to red. So we're going to multiply. My common denominator here is x minus 3. So I'm going to multiply all of these by x minus 3. X minus 3, x minus 3, and x minus 3. The good news is they cancel here and they cancel here. So I'm left with 4x equals. Now here I have to distribute. So I get 2x minus 6 plus 12. Wow, this is a simple problem after the last one. Subtract 2x. I get 2x equals 6 or x equals 3. Done. No, you are not. Did you hear my heater come on? It's June 2nd, and my heat is on. New York, you are one strange place. Ladies and gentlemen, what is the only answer I cannot have in my solution? What would make this denominator undefined? I hope you're all screaming, oh, 3 would make this undefined. Therefore, 3 cannot be in the solution. And since 3 was the only answer I came up with, the answer then is the empty set. There is no solution to this problem. Can't happen. Done. One more of these. So oh geez, gotta stop smoking or drinking coffee, one of the two. Don't like this plus, and I told you this was a tough one. If you hadn't done the problem before that like this, you should do this. This is the problem right here. We're going to convert this to negative x minus 3. It is the -1 rule. It is backwards. You know what? In your brain, you should be thinking, that looks funky. That looks weird. That looks hinky. Just that's a term from a stupid movie from a long time ago. Actually, good movie. Looks weird. So I'm going to turn it around. I want to make it look normal, semi-normal. All right, so I take out the negative. That's the -1 rule. All right, but now I got a negative over a negative, so those make positives. That makes my life even easier. Now, hopefully, you're all screaming, oh, this is x plus 3, x minus 3. And then, therefore, that is my common denominator, x plus 3, x minus 3. So I'm going to take each one of these and multiply it times x plus 3, x minus 3. Is that time consuming? Yes. Don't be lazy. We don't need any more lazy people. Oh, you know what I meant by that. Fun. Fun and lazy people. Wait. I don't even know if that makes sense. All right, over here, the x plus 3's cancel, and I got to distribute the 1. Well, that's kind of boring. It's just x minus 3 plus the x minus 3 cancel. Now I'm going to distribute this positive 2. So that's 2x plus 6. And all of this cancels with all of this, and it leaves me 4. Well, this isn't bad. This gives me 3x plus 3 equals 4. Divide by, or move the 3 over, I get 3x equals 1, or x equals, I gotta have the wrong answer. What the heck? X equals 1/3. I am going to check this one, only because it's a funky answer. By the way, the only answer I couldn't use is 3 or -3. 1/3's fine. But I could always check my answer. Let me get rid of all the garbage. So control division 1/3 stow x. What the? Control var x. Enter. And then I don't remember what this was. It was 1/x plus 3. Control division 1/x plus 3 minus 2/3 minus x. Control division 2/3 minus x. I get that can't be right. Alright, let's see what 4 over this is. 4 control division 4/x squared minus 9. If it turns out to be the exact same thing, you're good. We're done. Okay, so that's it for those kinds of problems. Now let's talk about factoring. Ooh, I'm so excited. We're gonna use our brain, and we're gonna use our calculator on these. So first things first, brain first. X cubed minus 2x squared minus 16x plus 32 equals 0. Anytime there are 4 terms, you need to factor by grouping. We're going to group those two together, and we're going to group those two together. And you're looking for a GCF. Well, the largest thing I can take out of these two things is an x squared. And I'm left with x minus 2. Copy over this sign, negative. And then look 16 and 32. Well, I can take a 16 out, and I'm left with x minus 2, not plus 2, because you're really taking out a negative 16. And the other thing you want to make sure you're doing is this needs to match this. It equals 0. Now, the common factor that these two things have is both of these terms have an x minus 2. So that's your first parentheses, x minus 2. Your second parentheses are going to be whatever remains when I take that out of both. And that remains x squared minus 16 equals 0. And so my answers are x minus 2, and this factors to x plus 4, x minus 4. But don't forget, we still want to know what our answers are. We still have to solve it. So my 3 answers are x equals 2, x equals negative 4, and x equals positive 4. Now I'm going to check this equation in my calculator. So I'm going to come over here. I'm only going to do this a couple times. I'm going to menu 331 it. But instead of a second degree polynomial, I now have a third degree polynomial. So now you'll notice there's 4 boxes. So I got to fill those with 1, negative 2, negative 16, 1, negative 2, negative 16, and positive 32. Hit OK. We don't need the positive. Sorry about that. That's probably going to actually crash the thing. OK. And hit enter. And there's my 3 answers. Negative 4, 2, and 4. All right, moving on. You're not allowed to just skip and just go right to the end. You have to show the work to progress from here down to this step. So, but what a great check. What a great check. This one's already set up for me, so I'm just going to group. I can take out just an x out of these. This is an interesting problem, but we'll just take out an x, and I'm left with x minus 3. And out of here, we're going to copy over the sign plus, and I can take a 6 out of here. 6, x minus 3 equals 0. So my answers are, my first set of parentheses is x minus 3. When I take that away from both, I'm left with x plus 6. Ka-ching. Man, this one looks so difficult. First things first, got to get it set equal to 0. 25x cubed minus 25x squared. All these huge, humongous numbers, Mr. Gross. I can't handle it. It's driving me crazy. I got to get rid of this dot. It's driving me crazy. All right. So, factor by grouping. Let's group these two. I can take out a 25x squared. Does that ring a bell to you guys? Does that look like a perfect square? To anyone? It does to me too. When I take that away from this, I'm left with just x minus. Now I'm taking this whole thing out, but I still got to put something here, and it's a 1 because 25 times 1 is 25. So even if you take everything out, you're still left with a 1. So don't forget that. Otherwise, I'm going to haunt you. Copy over the sign minus. There's really nothing I can take out of these except 1. So that's it. X. I took out a negative 1, really. So this is x minus 1. And remember what I told you. You want to make sure this matches this. If it doesn't, you did something estupido. All right, so let's see what we got now. That's my Spanish for the day. Anybody not like it? Ich kann in Deutsch reden für dich. Mein Deutsch ist nicht so schlecht. Aber wahrscheinlich wirst du mir nichts verstehen. I just said my German, I can do it in German, but German's not too bad, but you won't understand me. So, we take out the x minus 1. That's the first set, x minus 1. And then what's left over is 25x squared minus 1 equals 0. Well, I'm not done. I still got to factor that because that is the difference of perfect squares. It is 5x plus 1 and 5x minus 1. So my three answers are x equals 1, x equals negative 1/5. Do you guys see that? You want me to show you how to? I'll show you on this one how I'm doing that. I set each of these equal to 0. 5x minus 1 equals 0. I bring the 1 over, so I get 5x equals 1. And then I divide by 5, and I get x equals 1/5. I did the same thing here, but it's just negative 1/5. All right, those are my answers. How many I got left? Oh my gosh. All right, I'm going to do them all. Only because I have 0 life. You can do as many or as few as you want. 414. Why did I pick all of these to do? But now that I've done them, I don't want you to have nothing to do. So I'm going to bring the 42 over. I am going to go a little bit faster and try to get through these. So it's the same math over and over again. We're going to take out an x squared, left with x plus 6. This one's a little bit different, though. You want to pay attention to this one. Ka-ching, ka-ching, ka-ching. We're going to take out a plus 7, and I'm left with x plus 6. So my first set of parentheses is x plus 6. My second set is x squared plus 7 equals 0. Well, I'm done factoring because I can't factor x squared plus 7, but I still have to solve, and this is where the weird part comes from. This one gives me x equals negative 6. This one gives me x squared plus 7 equals 0. X squared equals negative 7. I still need to get x, so I need to take the square root of both sides. When you take the square root, you have to remember to put a plus or a minus. So over here, my two answers are x equals plus or minus I square roots of 7. Because the square root of a negative, really it's negative 1, is I square roots of 7. So these are my answers. That's a kind of hard one. All right, so 9x cubed. I'm getting hungry at 4:15 in the morning when most of us are sleeping. I wonder how long it'll take me to get through all these problems. More importantly, will you stay with me the entire time? Will you keep me company while I'm doing these problems? No, that's not creepy. It's not creepy at all. It's what normal people say at 4:15 in the morning. They want company. I really don't want your company. I'm just kidding. I just would rather you just kick some butt in math. And if you need my help, do it. We're going to group, brought the 8 over. We're going to group these. 9x squared is the GCF of this. And I'm left with, does that, ooh, wait, that's a perfect square, isn't it? I'm left with x plus 2. I'm going to take out a minus 4. Ooh, perfect square. And I'm left with x plus 2. Remember, those have to match. Right there. They got to match, match, and match. So my first set of parentheses is x plus 2. When I get rid of them, I'm left with this perfect square, 9x squared minus 4. I think many of my students got to the point where they saw this and then immediately just skipped to this step right here, x plus 2, 3x plus 2, and 3x minus 2. It's the difference of perfect squares. 3 times 3 is 9. 2 times 2 is 4. All right, so my three answers are x equals negative 2, x equals negative 2 over 3, and x equals positive 2 over 3. I'm not going through how to do that. That's straight from 9th grade algebra. You guys should be able to do that. This is going to be an interesting problem, so pay attention to that one. This one here is x cubed plus 4x squared minus 9x minus 36 equals 0. I have no idea why I just did that, but it was cool. All the cool kids are doing it. You'll see. Walk around your school, look around, see all the kids going. And you'll be like, that kid's cool. He must have watched Mr. Krause's videos. Man, I don't know why I just did that. I am going to take out an x squared, not an x cubed. We'll go to black because it looks good. And we're left with x plus 4. I'm going to take out a minus 9. I'm taking out a negative 9, so this is going to be x plus 4. So did you notice every time you take out a negative or every time you copy over negative, this sign changes? That should make sense to you. So my two parentheses are x plus 4 and x squared minus 9. Wait a second, that's the difference of perfect squares again. So it's really x plus 4, x plus 3, x minus 3 equals 0. So my three answers are x equals negative 4, x equals negative 3, and x equals positive 3. Amazing. All right, so we're going to do x to the 4th minus 36 equals 0. I'm going to factor this puppy. So that gives me x squared minus 6, x squared plus 6. Well, that's actually done factoring, but I'm not done with the problem because I still have to solve it. If I could find my mouse pointer. So I'm going to set each of these equal to 0. So I get x squared minus 6 equals 0, or x squared equals 6. Or when I take the square root of both sides and put a plus or minus, I get x equals plus or minus the square root of 6. There's two of my answers. This one's going to give me something a little more funky. Funky Cole Medina. That was a song from a long time ago. If your parents are listening, I bet they know that one. I get x squared equals negative 6. Now here comes the crazy part. I'm going to take the square root of both sides. And when I take the square root, you got to put a plus or minus. But we're taking the square root of a negative. And we just talked about that. That's going to be plus or minus I, because the square root of a negative is I. Square root of 6. It's actually negative 1. I think my computer's dying on me. So we're going to have to get to these much faster now. So I'm going to be talking really, really fast. Hopefully you understand me. This one's a little bit different. We're going to do x squared. This is the difference of perfect squares, so it's x squared minus 9. X squared plus 9 equals 0. This one can be continued factored, x plus 3, because that's, again, the difference of perfect squares, x minus 3. I'm going to turn off a few things so my computer has a few more resources. That's about all I can get rid of, I think. Get rid of that. How long have we been recording for? 59 minutes. Oh my God, you guys tired of seeing me? Let me just minimize that. I don't want to look at myself. All right, and then this is just x squared plus 9 equals 0. So my three answers are four answers. X equals negative 3. X equals positive 3. This one I'm going to have to set equal to 0. X squared plus 9 equals 0. X squared is equal to negative 9. You take the square root of both sides, and I get X equals, plus or minus. Now, 9 is a perfect square. So it's negative 9, so plus or minus 3i. All right. You don't want to divide by an x because it's going to eliminate one of your solutions. So it's really x cubed equals 81, minus 81x equals 0. Do not divide by an x. You'll lose a solution. First thing I'm going to do is take out a GCF, and I'm left with x squared minus 9 equals x squared minus, where the heck did I get 9 from? 81. I'm just going to the next step. Equals 0. Now I'm going to factor x plus 9, x minus 9 equals 0. So my three answers are, and if you divided by 0, you actually would have gotten rid of this first answer, is x equals 0, x equals negative 9, and x equals positive 9. Now, of course, the grown-up kid will go, oh, okay, my answers are negative 9, 0, and 9. Make it look all fancy. All right. So x to the fourth plus x squared minus 20 equals 0. How many of y'all freaking out about this one? Oh my God, what's this x to the fourth x squared thing? Don't understand. Just factor it like normal. Pretend like it's an x squared. If it was just an x squared, you would go x and x. And you'd say, okay, plus 5 and minus 4. Because these multiply to negative 20 and add up to positive 1. But it's not x and x, it's x squared and x squared. Wait a second. And then that's the difference of perfect squares. So I got to keep factoring. This one I'm just going to end up with x squared plus 5. This one I end up with x plus 2. X minus 2 equals 0. I should have been putting this equals 0 along. So now I'm going to try to skip steps. I think we've done this enough. This one's going to give me x equals plus or minus I radical 5. And this one's going to give me x equals negative 2 and x equals positive 2. Ooh, x to the 6th. Okay, let's pretend like the x to the 6th and the x cubed are not there. Let's just pretend like it's a normal x squared and x. So I put an x and I put an x. Multiply to 6, add up to 7. There it is. But it's not that. It's x to the 6. So this is x cubed, and this is x cubed. Now, this is going to be some funky stuff here, so make sure you pay attention. So, got to set each of these equal to 0. This one's going to be a little bit different. This does not include an I, because we have cubes. The only time we're going to do I is when we have even terms, mostly x squared. X cubed plus 1 equals 0. So this one's going to give me x cubed equals negative 6, or x cubed, x is equal to the cube root of negative 6. That's one of your answers, not plus or minus, just the cube root of negative 6. This one's going to give me x cubed equals the negative 1. Forgot to do the first step. Oops, I'm in blue. Negative 1. Now I'll take the cube root. And the cube root of negative 1 is, in fact, negative 1. Strange answer. Oh my God, these problems just keep coming along. So this one's going to give me, let's see if I can do this in my head, 3x cubed and 2x cubed minus 4 and plus 1. Just is. So this one gives me 3x cubed minus 4 equals 0. X cubed is going to be equal to 4 thirds. So x is equal to the cube root of 4/3. This one's going to give me x cubed is equal to negative 1/2, or x is equal to the cube root of negative 1 over 2, which is really equal to the negative 1 over the cube root of 2, which is really equal to the negative cube root of 2 over 2. Those are the official answers. It's getting a little funky. I don't like when my highest term is negative, so I'm going to move everything to the right side. So I get 4x to the 4th minus 26x squared plus 30. I don't ever remember doing these problems this year. I can take out a 2, so I'm left with 2x to the 4th minus 13x plus 15. And then I'm going to factor it some more. 2x and x, and we're going to go minus. That's not going to work. How about we do this? We go they're both going to be negative. And so if I put a 3 here and a 5 here, there it is, 3 and 5. Squared and squared. That's 10x. And that's 3x, that's 15x, there we go, or 13x. All right, so my two answers are going to be x equals plus or minus the square root of 3/2, and x equals plus or minus the square root of 5. Good enough? X to the 4th minus 7x squared plus 10 equals 0. X squared, ding, 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 ding. X squared, and we're going to go minus 5 minus 2, because that gives me my negative 7 and my positive 10. So my answers are x equals the square root, plus or minus, the square root of 2, and x equals plus or minus the square root of 5. All right, so this one's back to this one. 2x to the 4th plus 14x cubed minus 16x minus 112 equals 0. I'm going to take a 2x cubed out, and I'm left with x plus 7. I'm going to take out a negative 16, and I'm just guessing that 16 times 7 is 112. I'm pretty sure it is. So what I end up here with is, this is going to be an interesting problem right here. I end up with x plus 7 times 2x cubed minus 16. And then I end up with, I should have taken a 2 out of this. So I end up with I'm going to stop right here, because this one gives us a lot of strange answers, and I don't believe you're responsible for those two in the Algebra 2 trig anymore. I think that's a holdover problem from old math problems, so we're just going to skip that one. Sorry about that. Here we're going to take out an n cubed, and I'm left with n plus 6 equals 0. So my answers are n equals 0 and n equals negative 6. Wow, that was a tough one. 3 left, I hope? Yes. Factor out a common factor. I'm going to take out an x squared. I'm left with x plus 2. I'm going to take out a 25. Oh, look at that. Perfect squares. X plus 2. So my answers are x plus 2. And this is x squared minus 25. But I think I'm smart enough now to realize, oh, that's x plus 5. X minus 5. And my three answers are -2, -5, and +5. Two left. Nothing to take out. So it's going to be y squared and y squared. They got to multiply to positive 45, but they got to add up to a negative, so they're both going to be negative. And I think you all see this is -5 and -9. But this is the difference of perfect squares, so I have to keep going. Y squared minus 5, y plus 3, y minus 3. And equals 0. Equals 0. I'm being lazy. So this one's going to give me y squared equals 5, or y equals plus or minus radical 5. And then these are going to give me y equals -3 and y equals +3. Last question. All right, this one I can take out a GCF, 3r, and I'm left with r to the 4th plus 5r squared minus 6. And then I'm going to factor that r squared, just like saying r, because I'm a pirate. All right, it's 4:30 in the morning. Give an old man a break. Let's see. They got to multiply to 5 and add up. Multiply to -6 and add up to 5. So that means it's got to be a +6 and a -1. Oh, look. Difference of perfect squares. Again. So I get 3r, r squared plus 6. Oh, hold on there. And this is going to be r plus 1, r minus 1. All right. So this one gives me r equals 0. For those of you not seeing that, really what you do is take each piece and you set it equal to 0. So I take 3r and I set it equal to 0. I divide by 3 and divide by 3, and I get r equals 0. So anytime you take out a variable that's a GCF, it's got to be a variable, x, y, p, q, or r, you're going to have 0 as one of your answers. This one, if I set this equal to 0, I get r squared equal minus or plus 6 equals 0, or r squared equals -6. Or r is equal to plus or minus. Now, anytime you're going to take the square root of this, right? Plus or minus I square roots of 6. And this one gives me r equals -1 and r equals +1. Well, that's it, kids. There's day 2 review. Hopefully you got a lot out of it. Hopefully you made it to the end. If you did, I don't know, maybe you need to have your head examined, because that was a lot of work. Either that or you just want to kick butt on that Regents exam. Hit subscribe. I do a lot of work. You hit subscribe. Helps me out. Helps you out. I appreciate it. We're going to keep these videos coming. Hopefully they help you out and pass that Regents exam. Not only pass it, but seriously kick some butt on that Regents. I can't swear because I got a parent in the background going, that guy better not swear. Just kidding. Good luck on the Regents. Kick butt. And then after you do that, enjoy a restful summer. Just take the whole summer off. Take it off on me. I'll give it to you. Don't let anybody tell your parents you're not even going to mow the lawn, because you kick butt on the Regents. You don't have to mow the lawn. Tell them to come see me if they got issues. All right? See you guys.